The idea of traveling to another star system has long fascinated humanity. What if we could reach a planet beyond our solar system, one that might harbor life? Proxima Centauri b, the closest exoplanet to Earth, orbits the red dwarf star Proxima Centauri, a member of the Alpha Centauri star system. Located about 4.24 light-years away, this distant world has captivated astronomers as one of the most promising candidates for habitability. The mere thought of setting foot on its surface or discovering alien life fuels both scientific curiosity and the human spirit of exploration. It ignites our imagination, compelling us to question what lies beyond the familiar boundaries of our solar system. Could this distant world harbor microbial organisms or even more complex forms of life, adapted to extreme conditions? The journey to Proxima Centauri b, however, is not just a test of our technological capabilities but a challenge to our very understanding of space travel and habitability. How realistic is such an endeavor? Would we find a world teeming with possibilities, or a barren, inhospitable wasteland? The mysteries that await us upon arrival could redefine our perception of life in the universe and our place within it. Reaching Proxima Centauri b presents an enormous challenge, as the vast distance between our solar system and this exoplanet makes conventional space travel impractical. Traditional spacecraft, reliant on chemical propulsion, would take thousands of years to complete the journey. Even the fastest spacecraft ever constructed, such as the Parker Solar Probe, would need over 17,000 years to reach this distant world. This staggering time frame highlights the need for revolutionary advancements in space propulsion technology. However, innovative concepts like the Breakthrough Starshot initiative propose an alternative approach using laser-driven light sails to accelerate tiny probes to a fraction of the speed of light. By harnessing powerful ground-based lasers to push ultra-lightweight spacecraft, this initiative envisions reaching Proxima Centauri b in just 20 years. While such technology remains in its early stages, it represents a glimpse into the potential of near-light-speed interstellar travel. Yet, the challenge becomes even more formidable when considering human spaceflight. Unlike robotic probes, human missions require life support systems capable of sustaining travelers for decades, if not centuries. Radiation shielding would be critical to protect against cosmic rays and high-energy particles that permeate deep space. Additionally, maintaining physical and mental well-being over long-duration isolation would necessitate significant advances in space psychology, habitat design, and artificial gravity solutions to counteract the detrimental effects of prolonged weightlessness. In essence, while robotic exploration of Proxima Centauri b may be achievable within the next century, sending humans remains a far greater and more complex challenge, one that requires breakthroughs in propulsion, biology, and materials science. If we did manage to arrive at Proxima Centauri b, what kind of world would we encounter? The planet is in the habitable zone of its star, meaning it receives enough energy to potentially have liquid water. However, Proxima Centauri is a red dwarf, much smaller and cooler than our Sun. This means that Proxima Centauri b is likely tidally locked, with one side permanently facing the star while the other remains in eternal darkness. The extreme contrast in temperatures would make it a challenging environment for life as we know it, with one hemisphere scorched by constant radiation while the other remains frozen in perpetual night. The narrow region between these two extremes, known as the Terminator Zone, might be the most hospitable area for potential life, as temperatures there could be moderate enough to allow liquid water to exist. Yet, there are other challenges that make survival on Proxima Centauri b uncertain. The planet is bombarded with intense stellar flares from its parent star, Proxima Centauri, which releases powerful bursts of radiation. These flares could strip away the planet's atmosphere over time, leaving it vulnerable to the vacuum of space. Without a substantial atmosphere to protect it, the surface could be bathed in deadly ultraviolet and X-ray radiation, making it extremely inhospitable for life as we know it. However, if Proxima Centauri b has a thick, dense atmosphere rich in protective gases, or a strong magnetic field similar to Earth's, it might be able to shield itself from some of these harmful effects. In that case, conditions in certain regions of the planet could be stable enough to support microbial life or even more complex biological organisms adapted to extreme environments. The possibility of subterranean life is also intriguing. If surface conditions are too harsh, life could potentially exist below ground, shielded from radiation and extreme temperatures. Subsurface oceans, similar to those found on icy moons in our own solar system, could provide a refuge for microbial organisms. The presence of geothermal activity, driven by internal planetary heat, could sustain liquid water and provide essential energy sources for life. These factors suggest that while Proxima Centauri b is not an easy place for life to thrive, it still holds the potential for fascinating discoveries that could reshape our understanding of habitable worlds beyond Earth. Exploring this exoplanet would revolutionize our understanding of the universe, offering profound insights into the conditions necessary for life to exist beyond Earth. If we were to discover even the slightest sign of extraterrestrial life, be it microbial organisms or something more complex, it would fundamentally alter our perception of humanity's place in the cosmos, answering one of our species' most profound questions: are we alone? Such a discovery would challenge existing theories of biology, evolution, and the emergence of life, potentially proving that life is not a rare anomaly, but a natural consequence of planetary development. Even if Proxima Centauri b turned out to be an inhospitable wasteland, the knowledge gained from studying its surface, climate, and atmospheric composition would still be invaluable. It would provide crucial data on planetary formation, atmospheric retention, and the factors that contribute to a planet's potential for sustaining life. Additionally, exploring this distant world could advance our understanding of red dwarf star systems and the unique challenges they pose for habitability. Beyond the scientific implications, a mission to Proxima Centauri b could serve as a pivotal stepping stone for humanity's long-term ambitions in interstellar travel. It could lead to new breakthroughs in propulsion technology, space colonization strategies, and even the development of self-sustaining extraterrestrial habitats. If successful, such a mission could pave the way for humanity's eventual expansion beyond Earth, setting the stage for a future where interstellar exploration becomes a reality rather than a distant dream. For now, Proxima Centauri b remains just beyond our reach. But with rapid advancements in technology, it may not be long before we send robotic explorers or even humans on a journey to this distant world. The dream of interstellar travel is no longer confined to science fiction. It is becoming a serious scientific endeavor that could define the future of space exploration. Each new discovery in propulsion, artificial intelligence, and space habitation brings us closer to turning this dream into reality. The question is no longer just if we will explore the stars, but when. With the combined efforts of space agencies, private enterprises, and visionary scientists, a mission to Proxima Centauri b may be on the horizon sooner than we think. Imagine the thrill of witnessing humanity's first steps beyond the solar system, of finding alien landscapes, or even signs of extraterrestrial life. The future of space exploration is unfolding before our eyes, and it is only a matter of time before we take the next giant leap into the unknown.